Probability is a chance of prediction of happening of an event. It is a measure of the likelihood of a desired event's happening. So it is the ability to predict the outcome of an event. It simply refers to how likely something is going to happen. So that means the probability refers to the possibility of an event occurring. The probability of an event can only be between 0 and 1. So when the event is impossible, probability of occurring that event is 0. But when the event is sure, probability of occurring that event is 1. And all other events will have the probability between 0 and 1. We have next the experiments and random events. In probability theory, random experiments means a repeatable process that yields a result or an observation. So, random experiment, it is a repeatable process which it produce a result or an observation. When we say repeatable, paulit-ulit yung process na naglalaan ng result. So, for example, spinning the bottle. When spinning the bottle, what we usually see as an experiment is that the result is repeatable, which is it is either the head of the bottle or the bottom part of the bottle, and that is what we call random experiment. The second one is random events. A random event is an event that either happens or fails to happen as a result of an experiment. The same example with random experiment. So, when spinning again the bottle, the event, which is the bottom part of the bottle, may happen or may fail to happen. The other example is, let's say you have a 10 pair of t-shirt in your drawer. 8 of them are black and the 2 of them are white. So when picking a t-shirt, the event, which is the white t-shirt, may pick or may fail of being picked. So this is a random event. The white t-shirt may be pick or may fail of being picked. It is because most of the t-shirt that are in the drawer, most of them are black and only 2 white t-shirt. That is how random event means. A random event depends on the combined action of several factors which may not have been taken into consideration when setting up the experiment. So when tossing a coin, such factors may be the way we move our hands, the characteristics of the coin, or the position of the coin in our hands. The next one, the 2 special events for every experiment. Those are certain events and impossible events. Certain events is an event which happens with certitude at each repetition of an experiment. So it is an specific event that occurs after each repetition of an experiment. For example, getting dressed. Picking a 5 t-shirt with different styles, event one of the 5 t-shirt with different styles will appear. It is a certain event of the experiment. While the impossible event, it is an event which never happens in a random experiment. So, for example, when picking a t-shirt from a drawer which contains only white t-shirt, the event, which is a black t-shirt that is being picked, it is an impossible event. Impossible because the drawer only contains white t-shirt. So it is impossible that black will appear or will be being picked. We have next the contrary event. In the case of 5 t-shirt, let's denote by A the event consisting of the appearance of one of the faces, 2 or 5, and B the event consisting of the appearance of one of the faces, 1, 3, 4, or 6. We can define or we can say it was a contrary event when we observe that if the event A does not take place, then the event B takes place, and the other way around. The contrary of an event A is an event B, satisfying the property that at any repetition of the experiments, if the event A occurs then B does not occur. And if the event B occurs, then A does not occur. The event A and B are also called mutually exclusive events. So if B is the contrary of A, then A is the contrary of B. The next one are compatible events and incompatible events. So the event A and B are compatible if they are or if they occur simultaneously. For example, when throwing a card, the event A, an even number appear, and the event B, one of the numbers are 4 and 8, will be considered as compatible event. Well, let's give an example using 3 events. When 3 people throw a card, the event, which is A1, one of the faces 2 or 4 appears. The other people, which is A2, one of the faces 2 or 6 appears, and the third people, or the third person, which we called A3, one of the faces 2, 4, or 6 appears. It will be called compatible event since the outcome of the experiment is the appearance of the face with the number 2. All 3 events take place. The event A and C are incompatible if they cannot occur simultaneously. So, when rolling a card, the event A, an even number appears, and C, an odd number appears, are incompatible since even and odd numbers are not the same numbers. They cannot take place at the same time. One may notice that the event A and C are contrary events. As we all know, what makes an event contrary is when the events A occurs while B does not occur, and when the event B occur, then A does not occur. The next one is event implied by another event. So it is any event implies to certain events. So when we say the event A implies the event B, or the event B is implies by the event A, it is what we call event implied by another event. If the occurrence of the event A means that the event B occurs as well. So when throwing a card, the event A, which is 4, and the event B, number 4, appears, it is what we call event implied by another event.
Equally possible event. Equally like events are events that have the same theoretical probability or likelihood of occurring. Getting an even number on the toss of a die and getting an odd number on the toss of a die are equally like events, since the probabilities of each event are equal. Equally like means that each outcome of an experiment occurs with equal probability. For example, if you toss a fair six-sided die, each face 10, 11, 12, 13, 14, 15, and 10, 11, 12, 13, 14, 15. It's the same number, sir, because this is my example. So, ang different lang po nito ay yung second number is magkahiwalay-hiwalay sila. While ang ibang number is magkadikit-dikit. Or is as likely to occur as many other faces. If you toss a fair coin, a head and a tail are equally likely to occur. In other words, in a single toss of the coin, there are 2 possible outcomes. Since the coin is fair, each outcome should have an equally like chance of occurring. Next, general sample space. It's a fundamental aspect of statistics, and that's what we're going to discuss in today's report. General sample space, and this leads us to sample spaces and events. What is a sample space? And what is an event? A sample space is a set of all possible outcomes of a statistical experiment, and it is sometimes referred to as probability space. And outcomes are observations of the experiment, and they are sometimes referred to as sample points. An event is a subset of a sample space as discussed by Schaefer and Zhang. The example of general sample space is the set of all possible outcomes. For example, for the die it is the set 10, 11, 12, 13, 14, 15. And for the resistance problem, it is the set of all possible measured resistances. This set may be discrete or continuous. An event is a set of outcomes. The three most common ways to find a sample space are: number 1, to list all the possible outcomes. Number 2, create a tree diagram. Number 3, use a Venn diagram. For example, let's suppose we flip a coin and a roll die. When we flip a coin, there are only 2 possible outcomes, heads or tails. And when we roll a die, there are 6 possible outcomes, 10, 11, 12, 13, 14, 15. That means we have 2 events. Number 1, one event consists of heads and tails. Number 2, the other event consists of 10, 11, 12, 13, 14, and 15.
Union of events. The union of events A and B, denoted by A union B, consists of all outcomes that are in A or B or in both A and B. Like for example, if we are performing the experiment of throwing a dice, then there can be numerous events associated with it, one of which can be the number on top be a multiply of 3. A union is the area that belongs to one or both of 2 events, and an intersection is the area that belongs to both of those 2 events. The union of 2 events is written as follows: A union B. And the intersection of 2 events is written as A intersect B. Based on the definition, the union of 2 events always includes its intersections. Properties of probability. The probability of an event is defined as probability of event to number of favorable outcomes of event by total number of possible outcomes of event. The probability of a sure event or certain event is 1, and the probability of an impossible event is 0. The probability of an event is a number probability event such that 0 is less than or equal to probability event and less than or equal to 1. Probability is always a positive number. If A and B are 2 events that are mutually exclusive, then probability A is union with B to probability A plus probability B. An elementary event is an event having only one outcome. The sum of the probabilities of such event of an experiment is 1. The sum of probability or probabilities of an event and its complementary event is 1. probability A plus probability A is equal to 1. Probability A union by B to probability A plus probability B minus probability A intersect to B. Probability A union B is equal to probability A plus probability B sub by probability A union B. If A1, A2, A3 are mutually exclusive event, then probability A1 union by A2 union by A3 to probability A1 plus probability A2. Like for example, we have to find the probability of getting an even number when a dice is tossed. Set of numbers 1, 2, 3, 4, 5, and 6, and the favorable event is 2, 4, and 6. Number of favorable event is 3, and total number of outcomes is 6. Hence, probability equals to 3 by 6 equal to 1/2.